Good morning and welcome at this session of Science for Health. And this year's session will talk about a very exciting domain, which is gaining more and more interest. And in fact, it goes about data science and personalized medicine. Two topics that are creating more and more interest and will be more and more required going forward. So today we will highlight personalized medicine, but also how big data drives innovation in healthcare. Also how data can be used for various purposes, not just for driving innovation, doing research, but also in general to improve quality of care, also do population health, even also use of data for reimbursement or value-based healthcare. This session also has, as another very important aim, is to connect with each other, to start and spark new collaborations, develop new ideas as well, and so the networking opportunities will be also very important, as well as meeting with key experts in the field. I'm Ingrid Maas, I'm Managing Director of Innovigate. We are a strategy and specialized healthcare consulting company. And the last couple of years, we have specialized in the data and digital topic. And it's obvious I will be your chairwoman for the day. I would like to introduce to the first speaker today, and that will be Dirk Rijn. Dirk is chairman of the board of directors of Flanders Bio, and he will give an overview of the new initiatives that have been started in our local ecosystem here. So Dirk, the floor is yours.
Good morning, everybody. Healthy, unencumbered. Good morning to everybody getting here. So it's my pleasure and an honor to be able to open the Science for Health conference. So as Ingrid said, I'm chairman of Flanders Bio, and in daily life I run an investment fund and I invest in new innovation in Europe. As a kind of an introduction, so first a little bit about the meeting, Science for Health. It's a yearly event that I think has been organized now for the second time, in which we try to bring together researchers, business people, people from the government, investors, to try and do a little bit out of the box thinking and hopefully spark new ideas and new research initiatives, which is very good and supports obviously the value of this meeting, is that it is an initiative of a number of key stakeholders out of the ecosystem in Flanders. So I think very happy, obviously, to support these type of important events. As indicated last year, we had the event at the same location. We focused on cell therapy. There were about 327 people, as you can read on the slide. I understand today we're about 180 people that will be, plus people that will join live, obviously. But it offers, as Ingrid says, excellent opportunities to network. Last year there were about 19 cell therapy companies that basically presented their skills. But we had a very inspiring program with 15 speakers, local and international. And hopefully you agree with me that also this year it's a very inspiring program. We have top people from Israel, from the US, and obviously local heroes talking about data and personalized medicine. So what will happen during the course of the day? People will look a little bit at the value of data in a Belgian setting with, as indicated, people from US and from Netherlands and other countries. Israel, we can look a little bit at the international perspective. There will be examples from industry and from academia, patient representation. And I think we're all looking forward to the round table that addresses a little bit this fast evolving field and what the role is of Belgium and how we position. So the question is, I think we're all agreeing that the ecosystem in Belgium is flourishing, but okay, how good are we really, and are we leading, are we lagging? And for people that have not seen the data, Some of you have probably seen it, that Knowledge for Growth, but I find it a very interesting exercise in which the people from McKinsey have a set of variables that they track over time now, since 2015, in which they try to map the evolution of an ecosystem. And they've built a kind of biotech innovation index, which composes of 4 subscores. In which first they look at the innovation power of a region based on the number of patents that are being generated, the number of high impact publications, and which is your discovery index. Then they look on how good regions are in translating that innovation by creating new companies and financing new companies. How then the ecosystem is able to grow companies, and then ultimately to basically bring drugs to the patients. So you see on a number of dimensions that, and this is European, that Europe is doing well. The question, you see obviously the sector in itself is progressing. China is in the growth stage, really catching up, and there's a lot of money that's being released there. But on the translation index at Europe, I think we're lagging a little bit behind other regions. And if you look then specifically at Belgian data, obviously our ecosystem is growing and is gaining strength. So there's no debate about the discovery strength of our ecosystem. But if you're critical and you look at how we translate innovation into new companies and then are able to finance those companies, we're losing ground versus our competitors. And as an investor, I see that on the numbers of files that I get from France, from Switzerland, from other countries. So we have to stay resilient and recognize that. And collaboration between stakeholders at that level, I think, is critical. The very good thing is that, and I'll come back that on the next slide, if you look at the barriers to basically build our ecosystem, there's one barrier which I think is gently drifting away and is getting a lot of support, is basically money. So if you look at money that is available now to basically start companies, and I know if you witnessed last week, the weeks before, for the first time in Europe, we have 2 $1 billion funds for early innovation. That means that people put tickets in from 15, 20 million in very young companies. That is US-style financing. So that is very, very good. I think we get more international investors in our ecosystem, and also people that then go to NASDAQ. I think the performance, the capacity of raising money there, shareholder value is the same. So that's the good news. Where are we for the ecosystem? Do we have opportunity to improve in that translation? So if you look at the number of companies that are created in Belgium and you compare it to Switzerland, UK, France, we're not as strong anymore. And if you look at, I think the 2 challenges that we may have is you look at talent. We have a big portion of vacancies in new capabilities, for instance, production of new technologies. And then for the topic of today, I think if we compare based on the investment that is done in health tech type of initiative and data type of initiative, I think there's opportunity for growth. This is a slide, and so these are the type of funding initiatives that have been happening the last couple of years with the focus on data, real world evidence, real world data. And unfortunately, these are significant numbers. But at the level of some of our initiatives, we're not at the level of having initiatives of 30, 40, or 50 million in data initiatives. So there's definitely a challenge for us ahead, and that's why this meeting, I think, is so important, because we obviously address that. I think what has happened the last couple of months, obviously through the COVID pandemic, I think our political leaders have realized how strong the ecosystem is. I think we have had the leadership position in not only the discovery of new vaccines, in the manufacturing of new vaccines, and it's clear that the political system has obviously witnessed that. And so I think all of you are probably aware that at the level of the federal government, there's a new initiative that has been launched at the Health in the Biotech Valley of Tomorrow, in which you really see that the political leaders are now much more focused on our ecosystem, on our industry, and are willing to basically invest in it. This is a little bit a summary of the plans that people have currently at the level of the federal government, and that will be translated into the different levels. And while, as I indicated, people have indicated talent as a big challenge for our sector, they have indicated, obviously, that you need to keep the business climate here with all the incentives of the government a stable environment. Health data and consolidation of data is now clearly on the map, and that is important, and that will be followed. And the last thing is on this translation, that I think in Flanders we can work better together to translate innovation into new companies. So, as a kind of a sidekick, last year the meeting was focused, this meeting was focused on cell and gene therapy or cell therapy. I think this is an area where we have been active. It's interesting to see that this area now also is part of that federal map and of the focus of the government, and that this is one of the initiatives, I think, where different parties are working together to improve our competitive position. If we look a little bit at the Flemish level and what is happening at the Flemish level, hopefully people in the room are available. These are a little bit the strategic pillars that we have at Flanders Bio to the different initiatives we try to coordinate. There's one block in there which we call the Connect block. It's obviously the role of a network organization to connect people. I think we have witnessed the last couple of years that obviously, I think Flanders Bio works a little bit works in the life science area as a network organization with other people. That you have obviously also the medtech world, and then you have the ICT, the software world, and that these worlds were merging, but that these are very different worlds with different rules, different dynamics, different timelines. And that if we wanted to remain our competitive position in the ecosystem, we had to do something on this merge of these different ecosystems itself. That has now translated in the creation of a Flemish spearpunt cluster called Flanders Health Tech, which is really focused on this crossover area, which we call the health tech area, between these three worlds, and where obviously you all will agree data is one of the key components to basically be successful. So the spearpunt cluster, I think, is now recognized or will be a kind of a central actor in this new domain. And we've been very lucky to have all the key stakeholders, small, large companies, universities, the government, hospitals involved in a coordinated exercise to basically increase collaboration between the different stakeholders in that crossover area, with the key objective to improve the competitiveness of our companies. And we believe if we will be successful, that this can create 15,000 new jobs and can accelerate the growth of our ecosystem. Currently, it's a cluster that has 75 members that are basically committed to work closely together with each other, and create new out-of-the-box initiatives and progress the area. So what is in it? But what does the spearpunt cluster do is basically a dedicated partner matching organization, so stimulate crossover innovation between these sectors and between the players in the sectors. The universities are very engaged as they see this as a way of getting easier access to companies and facilitate the cooperation between themselves and then the ecosystem. The hospitals are involved, as obviously they are, I think, the radar where we can identify needs and input for the definition of the roadmap of the spearpunt cluster. And as a general type of objective, it is to, over time, develop a roadmap and a vision on how this crossover area should develop with a single voice and a single point of contact. And then there is an initial funding from the Flemish government but that through this initiative, people would get access to extra funding then at hopefully federal and definitely European level. So that is, I think, a little bit the summary of the Spearpin cluster. There have been 4 areas defined in which specific calls will be organized. You read the themes on this slide, so value-based efficient healthcare, getting access to more easy diagnostic data, improved clinical trial management, better cost management in hospitals. You have disruptive health solutions, would include new sensors, using sensors to basically follow patients when they leave the hospital, patient care pathways, personalized medicine of basically targeting specific areas. And then last, digital medicine is basically using digital tools to change behavior and impact treatment. So as I indicated before, central of this whole initiative is data, getting access to data, the right data, being able to analyze data. And that is obviously the focus of today. So I think my call for action for us as an audience, as an ecosystem, is that I think we need to remain vigilant, and that I think there is room for improvement of strengthening collaborations to improve, I think, bringing innovation, not only that it's developed in the universities, but ultimately bringing it to the patient. And that in this whole journey, and then definitely in the personalized medicine world, having access to real-world data is crucial. How will we use it? And then the question is, we're lagging behind. What do we need to do to keep up with our neighboring customers? What type of initiatives do we need to install? So that is the agenda for today. I hope you will have a very thought-provoking day with new ideas and spark new ideas. In name of the organizing bodies, I want to have a special thanks to the scientific committee. You can read the names on the list. And then I just want to wish you an enjoyable day and have a great meeting. Thank you very much.
Thank you, Dirk. So in fact, the program for today will be addressing multiple aspects around data. When we speak about data, that can be clinical data, can be omic data, genomic data, can be imaging data, can be all kinds of data being gathered remotely, for example, through wearables, sensors. So more and more we will, throughout our lives, collect data. Well, of course, to turn this data into something insightful, something meaningful, we also call it real-world evidence. Well, that's in fact a next important step to take. For that, we see multiple advantages, or advances first, in the world of analytics. Dealing with big data, interpreting the data, the topic of artificial intelligence, machine learning are the obvious new methods, in fact, to turn real-world data into real-world evidence. Well, today we will talk about the future of artificial intelligence in healthcare. We will talk about how data can be extracted, but also how it can be annotated, standardized, and also combined, in fact, with other types of data and with powerful analytical opportunities. We will also talk about how data can be gathered and analyzed in an ethical way. We will hear about the patient perspective. We will also hear about the ethical perspective on how we can use and reuse data in a safe and privacy-preserved way. And also, we will talk about using all these kinds of tools in the medical practice, in research, in all kinds of applications that could stimulate innovation and could also stimulate the progress of healthcare. We'll have a group of very interesting speakers today, giving interesting examples on how data can be applied and can be used. And we also will have the opportunity after each speech to have questions and answers. Of course, coming here from the room, but there are also a group of people participating to this conference online, and also I encourage everyone to also put questions forward so that we can also have a debate after each presentation. So that leads us to the first speaker, and the first speaker is Gabriel Chodik. Gabriel is in fact head of the epidemiology and database research department at the Maccabi Tech University, and it's a university based in Israel, in Tel Aviv. In fact, he is an embedded researcher in a very large healthcare provider organization, and he is responsible both for externally funded and operationally focused observational data research. He performs comparative effectiveness analysis based on data being gathered in clinical practice. Gabriel will talk about the use of real-world evidence research in primary care settings, achievements, challenges, and future perspectives from the Maccabi Tech perspective. So with that, Gabriel, I give you the word.
Thank you so much. Thank you so much. Good morning, and thank you for the opportunity to present what we do in Maccabi and to attend this interesting meeting. Where do I get? So for those of you who would like to know more about what we do in Maccabi and how we utilize data for better health, the Harvard Business School has published a case study a couple of years ago, and I think it's a good read that summarizes what I'm going to talk about today, without the COVID, of course. And maybe just a very quick word about the Israeli organization of healthcare services. It's quite different from the Belgian one. Israel enjoys a Universal Health Insurance Act since 1995, where every citizen is eligible for a free basket of services given by 4 HMOs. Maccabi Healthcare Services is one of them. Membership is open and free to everyone. Every citizen must be member of one and only one HMO, and we cannot bar anyone from joining. The funding comes both from the health taxpayer tax and the general taxation. Maccabi accounts for about 25% of the Israeli population, which means that we have about 2.6 million members, 9,000 employees, including 5,000 independent physicians. And luckily, the turnover is very low. Less than 1% of our members are leaving Maccabi annually. That's why we can follow them retrospectively for many, many years, primarily from cradle to grave. We also have a network of hospitals, and we own or contract with over 700 pharmacies countrywide. So we provide service to the entire Israel country, and the total income budget is about $4.5 billion. We are part of the HCSRN, the Healthcare Services Research Network in the US, and we are the only non-US organization. And even within US standards, we are the third largest, and we have almost the longest history of medical records that goes back to early 90s. We also characterized by a very young population. This is a young nation. 40% of our members are adolescents or children, which is very different from the situation both in the US and Europe. In terms of data, Maccabi is has a centralized databases where all the data are transferred on a daily, or sometimes several times a day, to the central headquarters, where the major servers of the network provide communication to all physician, nurse stations, pharmacies, hospitals. We luckily have only one lab to provide service to in the entire network, so we don't have to deal with different calibrations and different methods. Everything is being shipped from the collection points to the central lab. And that's include also the image center physiotherapy. And of course, we provide our members an option to log in to their medical records and obtain their tests, medication, communicate with the physician, etc., as done in many other healthcare services. So all the data are collected. I know that in Europe there were some issues with identity number, which was more challenging to cross-link data. In Israel, we followed the Swedish system where every citizen gets an ID at birth. So connection and cross-linkage between different databases, such as the National Cancer Registry and the Maccabi data, is very easy, and we use it to collect information on all those issues. The medical record is fully computerized. All prescriptions, consultation, alerts, reminders, and a physician portal, everything is being up and running for more than 15 years now. And just to give an idea of the amount of services that Maccabi performs, this is only the annual figure for imaging. And the amount of data in terms of memory are tremendously large, so we're now moving to clouding, otherwise would not be able to manage that and investigate that. So we use also clouding, which is more challenging from the regulatory aspects, but I will not be talking about that today. On top of the crude data, over the years, we've been collecting data and opening or founding registries of chronically ill patients that include diabetes, cardiovascular, infertility, and you can see the list over here. The largest one is hypertension. Now, when I say we manage registries, it's not only from the data aspect. We also provide every physician a list of his patient, her patients that are included in the registry, and the physician has to validate. So we have a double validation. The algorithm for identifying patients may include also diagnosis, hospitalization, lab tests, medications, etc. And we use this as a building block for our research. We also, in recent years, have developed patient-reported outcomes to collect information or more subjective information, such as quality of life, pain, and other symptoms that are not routinely captured in the EMR. I must say a word about the COVID-19. You cannot have a discussion about data without mentioning that. So I would just like to give you an example of how data provide, or data science provide better health. One example was in very early days of the epidemics, where there was a paper published in the Journal of Travel Medicine and some other journals, an hypothesis that ACE inhibitors may increase patients' risk for COVID-19. Now, as I told you, we have over 300,000 patients with hypertension. A physician would seize their ACE inhibitors or ARBs medication, would have many, thousands of patients with uncontrolled hypertension, which may cause, of course, complications such as cardiovascular disease, etc. And this is only based on a hypothesis with no data. And the paper was published on March 17. On March 25, we have submitted a paper that really shows that there is no association between ACE inhibitors and COVID-19 infection. You know, we got IRB, we've written the protocol, collected the data, and made the analysis within 48 hours. I mean, I wouldn't imagine anything like this before the epidemics. On May 15, there was a literature review, a meta-analysis that really shows that there is no such association. So this is the way, the pace that research is being done nowadays. Another example relates to the Pfizer vaccine. The phase 3 trial was published on December 31st, 2020, showing an effectiveness of about 52% for the first dose and over 90% for the second dose. And now this, and Israel began was one of the very early to one of the countries that rolled the vaccination campaign very early. And parallel to the rollout of the immunization, there was the third wave came out. So it was a funny situation where we're vaccinating more and more people, but the numbers of patients are increasing. And there was a very urgent question from our executive in Maccabi: does the vaccine really works in the real world? The concern was major because, as you may remember, the vaccine requires a frozen chain. And there were some suspicions that we do not provide a frozen chain for the vaccine, and it loses its effectiveness. So we have conducted a study showing the effectiveness of disease and published that in the medRxiv on January 29th, showing the high effectiveness of the first dose within less than 4 weeks from the third phase 3 publication. We have used the fact that in the Pfizer trial, the first 7 days had no effect on infection risk. You can see that over there, that in very early days, the vaccine provides no effectiveness whatsoever. So we used this period as a control period to compare incidence afterwards. So we didn't have a vaccinee, non-vaccinee study, as many others did. We just used only vaccinated people. And we've shown that the first dose had an effectiveness, a real-world effectiveness of 54%, and this was the first real-world data analysis of the Pfizer vaccine. The other HMO in Israel has published vaccinated and non-vaccinated study that appeared in the New England Journal of Medicine, showing the same result, but they've published that only in mid-April, 3 months after the burning questions. So I think that speed and getting a rapid response to burning questions is the major idea behind all, the actual result. We also examined the effectiveness by other way. We looked at the CT, the viral load of those that were infected in both periods, and we've shown that the viral load decreases. Namely, the CT increases, which is another way of showing the effectiveness of the first dose, together with what I've shown you earlier. So we had to provide very quick answers to burning questions, and that's the very similar analysis for the second dose that was published later on, showing again a very high effectiveness of the vaccine in the first month from immunization. Unfortunately, somewhere in July, we've noticed that infection rates increase, and indeed, when we looked at those that were infected in June, July 2021, and we looked at the time where they got their second dose, we've seen that those that were vaccinated in January had a twofold greater risk of infection compared to those that were vaccinated in April. They all got infected in July. So our interpretation of the data was that the vaccine is waning, the effectiveness is waning, and it's not the variant. It's not the Delta variant that affects the effectiveness. It's just the time since second dose. And that really boosted or encouraged the Maccabi headquarters and also the Ministry of Health to provide the third dose for the entire country. So that was, just an example of how we use data in very rapid analysis to provide answers, quick answers, evidence-based answers to the executives in Maccabi. But now I want to go back to big data analytics, which I think is more the focus of today's meeting. Most of the research that is being done is primarily descriptive, such as what I've just shown for COVID-19. It shows you what happened, the association. It has a great importance, but yet we want to move forward. We want to move for predictive studies that tells you what will happen, and prescriptive studies, namely those that will tell you what to do. I'm talking about the care provider or the decision makers. And this is very challenging. One example is a recent study that we did on HPV vaccination using social network. As I told you, we have 2.6 million members, including thousands of girls at 8th grade. And we noticed that the uptake of HPV vaccine in this age is very low. So we wonder whether a social network campaign using Facebook, or which is now called Meta, may help in increasing the uptake. We cannot campaign, get direct access to those teenagers because they don't use Facebook, one, and second, we don't have the ethical approval for that. But we can approach their mothers. So we identified mothers of 8th grade girls or adolescents in Maccabi, and they were randomly allocated to two groups, one intervention, and 20% were kept for control. And during the summer of 2018, we provided them with a campaign talking about cancer and STIs in their Facebook. And indeed, we saw that for some, the lower socioeconomic levels, the campaign had an effect, but then for the very low socioeconomic, the campaign had a negative effect. So that learned us a lesson that Facebook campaigns have to be very carefully tailored, and that appeared in gynecology, oncology last year, and I'll be happy to share the results. That's one option. Second is using data for prediction. And I think the first example of using data for predictive medicine is the use of lab tests to identify early identification of colorectal cancer. The former head of the institute was a family physician, and one of her patients back in 2006 was diagnosed with colorectal cancer. Now, the patient was visiting the office quite often and had many lab tests taken prior to his disease. And when you look at the results, they all came normal. I mean, they all came in black. Once it comes in black, the test is normal, within the normal range. But when you look at closely, you see that his hemoglobin levels were declining over time. That means the patient was bleeding, but the physician cannot notice that. I mean, he cannot do the math during the 5-minute visit to identify the reduction within the normal range. But the computer can do it quite easily. So we were approached at the time, and we've shown that in a descriptive study how early hemoglobin levels decline before diagnosis. And actually, if you look at the data closely, you can identify or diagnose the patient 2 years prior to their regular diagnosis date. So we were approached by a team of algorithmics and mathematicians that made their fortune in algo trading and the New York Stock Exchange, and they came up with an algorithm that identify patients only according to their change in hemoglobin levels within the normal range. It took them something like 3 months to develop the algorithm. It took us 6 years to implement it. Implementation is the most challenging. It's not the algorithmics. It's not the mathematicians. It's the medical informatics team. The most challenging way, I think, is how to implement good algorithm into the system. So the computer can calculate, but who takes the liability? Who's sending the patient to colonoscopy? All those decisions are very difficult and very complicated. Eventually, in 2016, we've implemented this algorithm that goes over blood tests for those that are within the screening age, and if it's positive, the patient is automatically referred to colonoscopy. And indeed, we have thousands of cases that were referred, and many of them, something like 7% actually had cancer, another 31% had positive findings based only on hemoglobin level. A second development is K-Health. It's a free app that it's a symptom checker essentially, but it's not a regular symptom checker. It's not based on rule-based algorithm, but it's absolutely 100% AI. It's based on 400 million visits in Maccabi, where the physician has written the free text, taking the anamnesis, symptoms, complaints of the patient, and eventually giving a diagnosis. So they have taken this app, this huge amount of data, free text data, and they were able to reverse engineer that. So when you have a complaint, the computer, the app will ask you a second question based on your response and based on the data. So it really changes between, it's absolutely personalized medicine because it changed between patient characteristics, responses, medical history, etc., and was a very challenging way to deal with the natural language processing, especially when it's part in Hebrew, part in English. It was very time-consuming and effort-consuming, and eventually they were able to get a very good app that's already operative. They are the first health data unicorn coming from Israel. They are now got investment from Elon Musk and other investors, and they offer their services in the US where physicians are not available for those that don't have insurance or want to consult with the machine before they go to the physician. And they also offer a session with the physician if something suspected is coming up. So this is a really innovative app that came from Maccabi. We also look at drug repurposing, identifying new indication for all medication. Statins and blood pressure is one example. When we talk about personalized medicine, we have the phenotypic, the digital information. We have the biologic information. We also should have the genetic information. And for that purpose, we've in 2017 we've opened a biobank, taking advantage of having only one lab. So instead of doing what the UK biobank and many other biobanks have done, we have piggybacked what we already do. So when patient is opting into the biobank, one tube from every blood test or urine test, one tube is kept for research. So essentially the cost is minimal. We use the regular shipment of the biospecimen, and the storage is done in where the central lab is located. And at a very small budget, we were able to open a biobank, which is fully representative. Currently, and this is the daily number of tests that are being done regularly in the Maccabi Mega Lab. And currently, of course, we have an electronic patient consent form. And currently, we have 200,000 adults, Maccabi members, that already consented and opted in to biobank, which is almost 15% of the adults in Maccabi. So out of 6 adults, we not only have all the medical history, but also either blood or urine test. And recently, we've have a contract with a US company to sequence this huge amount of data, and hopefully in 3 years from now, we're going to have the genetic information embedded in the EMR side by side to the phenotypic data. So that's a very quick summary, and sorry for rushing on too many issues about the data science in Maccabi Tech. Yeah, thank you.
Great, thank you for this inspiring examples on how data can be used in multiple applications to improve care and have more evidence on better care provision. So we have time for a couple of questions from the room. Yes, there on this side.
Thanks for this. Does it work? Yeah. Thanks for this very impressive list of achievements. I would say. I am wondering about the data security of this genetic data of your last topic. So you're gonna work with the US company, but that doesn't matter. But how would you guarantee the patient that consented to use their data that their data wouldn't leak due to hackers? That's my basic question. Yeah.
Okay.
So the typical way we share data is having an API for the external researchers where the data is on our premise, on Maccabi premise. But I have to be honest, no one can really guarantee that it will not, no cyber attacks. And Israel, we are being attacked many times. There was statistics that we have something like 100,000 attacks, cyber attacks on the Israeli healthcare system a day. One of our hospitals were affected negatively, and actually the entire computer system has been shut down. We do our best efforts. I mean, but it's always a risk that you take. But just without getting into too much discussion on the cyber security, legally and ethically, the data is always on Maccabi premise, and it cannot be cross-linked to any other data. So, and you work from the distance. But we are living in a world where everything is possible. We do our best efforts, and yet we disclose that. I mean, it's well known that Israel is being attacked again and again with cyber attacks, and our patients know that. And yet, the response rate and the consent rate are very high, despite all that.
Good. Thank you. Other question here. Wait. There's a microphone coming. Okay.
Thank you.
Yes, go ahead.
Thank you for this very inspiring talk. I think you showed that you have a very comprehensive and forward-thinking data strategy. My question is about your organization in relation with the other health services in your country. You mentioned there were 4 or 5. Do you also have a strategy within Israel to benchmark or compare quality or services in these health services? And could you share a couple of words about that?
So the idea behind the Israeli National Health Insurance Act is that all HMOs provide the same service. We are all going according to the same health basket. None of us is collecting money. There are no co-payments. Membership is absolutely free. The only way we can compete between ourselves is over quality of care. So when we provide patients with, virtual visits to their physician, or access to their EMR, or where they don't have to call anyone or attend the office to get a prescription, this is the way that the HMOs are competing for better care and better service. And I think it goes very well. I mean, the other HMO, the Clalit, it counts for about 53% of the total population in Israel, and they had done a great improvement over the years with their technological efforts, and they also have a data science team and research institute, and I think it's a great competition. I think that to keep the competition going on, I think that we should have a minimal interaction between us.
Okay, good. Thank you. Unfortunately, we have to close the questioning.
Thank you so much.
Thank you very much for sharing your examples. We will go on with another interesting example, but from a different perspective. So Gijs de Wit will speak. He is a PhD at the group of Emile Vroest in the Netherlands Cancer Institute. And one of the main things Gijs will talk about is the so-called DRUP study, which is in fact a very large-scale study where biomarker data is being used in combination with off-label cancer therapies. In fact, the study, and I think you will talk in further detail about it, how the use of biomarkers could be used to improve outcomes of therapies for cancer patients. So, yes, the word is yours.
Thank you very much for the kind introduction. So yeah, like you said, I'm a PhD student and a clinician, and I'm working on the repurposing of targeted anti-cancer drugs in the drug rediscovery protocol, which we shortened by the DRUP trial. And I hope this talk won't be too technical, but I'll try to cohesively explain everything. And we've been open for the past 5 years, open for inclusion and treating patients. And I work in the NKI, the Netherlands Cancer Institute, and the Netherlands Cancer Institute describes itself as a comprehensive cancer center, which means that there's a hospital that is there for specialized care of cancer patients, but there's also a research institute that focuses on the improvement of cancer care, and they list these 5 themes as the themes to improve cancer care. And my group, which is the group of Emil Voest, mostly focuses on precision oncology, but there's some overlap with fundamental research and immunotherapy. But as a clinician, I'm on the clinical side of the spectrum, and that's what I'll be talking about this talk. So for a long time, and we still do this, we have approached cancer care with a one-treatment-fits-all kind of approach, in which a certain group of patients with one disease, for instance colon cancer, are treated all with the same type of therapy. And the best example of this, and the most well-known, is of course chemotherapy. And in this group of patients, we see that some patients have a therapy effect, some patients have no effect, and in others there's even adverse effects, of course, very well known. But our belief is that we can, with a shift to a more personalized medicine approach, we can greatly improve the treatment effect of anti-cancer therapy, and this personalized medicine approach would be genomics guided, so that a group of patients that's on the surface very similar, because they all have the same tumor type, colon cancer in this case, are treated with different kinds of treatments simply because the genetic makeup of their cancer is so different. So on the surface they look similar, but when you look more to the details, these patients are very different from each other and receive different treatments, and we think that this greatly can improve treatment effect. So there are some requirements for this shift in approach to how we treat cancer. And I think one that immediately springs to mind is the development of new drugs, but we also have to improve access to diagnostic or develop new ways to diagnose molecular or genomic alterations in cancer. And because the patient groups become more specified, they also become smaller, and that's why we need big data and innovative trial designs to test these new treatments. And after all this still needs to be affordable. We need to be able to pay for it after all. And our ability to perform genomic profiling on not only the human genome, but also the human cancer genome, has greatly propelled us towards this idea of a personalized cancer therapy, or personalized anti-cancer treatment. And what we see is that large-scale genomic profiling, so taking a biopsy out of the tumor and performing whole genome sequencing or whole exome sequencing on these, identifies potential genetic variants that can be targeted with certain drugs. And we see that these drugs are being developed. So this is a schematic illustration of the genomic markers on the left in colorectal cancer and on the right in lung cancer, with the not only with the genomic alterations that we can target, but also with the drugs that target these alterations. And what you see is that in some, for some targets, we have up to 6 different therapies have been developed or are, as of right now, in development. And this is just to show that the landscape in targeted therapy is vastly changing very quickly. The market is flooded with all types of different anti-cancer therapies. So the new drugs are being developed, and we have the ability to profile the cancer genome, but how do we know in which patients we have to look for these variants? And so the Hardwicke Medical Foundation, which is a company in the Netherlands that has the ability to perform whole genome sequencing, has created a database in which they have performed whole genome sequencing on tumors of all different types. And what they saw was that in 31% of all patients, a level A actionable event was found, which means that for the variant that was found, a treatment, a very specific targeted therapy, was already available on the market. 18% of all patients had the variant where, that the therapy was registered for, but in 13% of the patients had actually a tumor type for which the therapy was not registered. So I'll give you an example. An HER2 amplification is found in breast cancer patients, and we know we have targeted treatments that can target the HER2 amplification. And that is often seen in breast cancer. The targeted therapy is registered for breast cancer, so the patient can get treatment for it. But if the same HER2 amplification is found in colorectal cancer, there's no way for this patient to receive the same treatment because the treatment wasn't registered for colorectal cancer. Now, so what we see is that these not very uncommon variants are found in tumor types for which the drugs are not registered, like I just said. And one way to solve this is off-label access. But this is often there's very limited access in receiving off-label drugs. And if access can be provided, there's no way to systematically collect the outcome data of this all. And this is exactly the idea that the drug study is based on, so the drug rediscovery protocol. We give patients treatment based on a molecular profile with approved, so already approved targeted therapies, but the patient falls outside of the indication because the drug isn't registered for their tumor type. And the patients we treat in DRUP are therapy refractory, which means that they have no regular treatment options left. And how we measure the outcomes is that we measure clinical benefit, so that is partial or complete response, remission, or stable disease at 16 weeks of therapy. We measure safety data, and what's more is that to add to the database, the genomic database that I just showed you, every patient that is treated in DRUP undergoes a pre-treatment biopsy on which whole genome sequencing and RNA analysis can be done. So in that way, for instance, what we can do is retrospectively analyze the genome in the patients that respond to the therapy, compare that to the patients that do not respond to the therapy, and see if there's any change there. Okay, so how does this work in practice? When an actionable variant is found in a metastatic cancer patient, the patient is submitted to the study team, often with help from molecular experts. We see if a patient is eligible or not. And if the patient is eligible, a mandatory pre-treatment biopsy is done, screening is performed, and if all requirements are met, the patient can start the treatment in one of our cohorts. A cohort, all the patients in the cohorts have the 3 variables, all the same variables. So they have one tumor type, they have all the same molecular profile, and they all are treated with the same study drug. In some cohorts, there are only 2 variables. Those are the tumor-agnostic cohorts, in which we treat patients with multiple tumor types, but all with the same molecular profile, and we treat them with the same study drug. And the way DRUP is set up is that we can have an unlimited amount of cohorts simultaneously. And what we do is that we basically do some signal finding. So in the first stage, we treat 8 patients. And if there's no benefit at all after 16 weeks in these 8 patients, there's no signal, the cohort is closed. However, if there is even 1 patient or more that shows clinical benefit after 16 weeks of therapy, the cohort proceeds to stage 2, in which 60 more patients are being treated, so 24 in total, and we try to confirm the signal. If in these 24 patients, 5 patients or more have clinical benefit after 16 weeks, then we call a cohort successful. We analyze the whole genome sequencing data, and we try to publish and share the results to the outside world. If less than 5 patients have clinical benefit after 16 weeks, then the cohort is closed. What's more, if a second stage cohort is successful, we often get into a very long discussion with the pharmaceutical company that provides the drug and with the health insurance in the Netherlands. And we try to see if we can expand the cohort to even further confirm the signal we found, and in that way have more clinical evidence that the drug is working for this indication. And in that way we can broaden the indications of a single therapeutic. So like I said in the beginning, we've been open for inclusion for 5 years. And in these 5 years, we have almost 2,000 cases submitted to us, out of 35 participating Dutch hospitals. So we're very much a nationwide study. And a little more than half of these patients was actually eligible for treatment. And these patients were all treated with one of these 35 different pharmaceutics, 35 different drugs that are provided by us by 14 different pharmaceutical companies. So we're very much created in these past 5 years a platform for basically nationwide off-label anti-cancer therapy. And I'd very much like to share some results with you all, some general, some cohort specific. So this is a graph displaying the 500 patients that were treated in DRUP. So when we first reached the hallmark of 500 patients, we analyzed them, and we observed that in 33% of all patients, a clinical benefit was observed after 16 weeks of treatment, which actually exceeded our expectations a little bit, since, and I would like to remind you, these patients had no other treatment options left. So that's a pretty good result for us. And this graph shows the amount of change in the tumor burden in the patient compared to the baseline CT scan. So on the left here, we saw some tumor growth, and on the right are the patients in which we saw tumor shrinkage. Then some cohort specifics results. So the first cohort we completed was the cohort in which we treated microsatellite unstable tumors with nivolumab, so immunotherapy. And we saw a whopping 67% clinical benefit rate and almost objective response rate of around 40%, which is an incredible result. And I'm still, especially the median progression-free survival that was not reached after 16.5 months, and even more, the 7 patients from these original 24 that still experienced clinical benefits, so there was no progression of disease after more than 3 years after they started study treatment. This data still amazes me, since originally there was no other treatment options left for these patients. And this is actually the cohort that proceeded to a third stage, which is almost completed now. We've almost treated 130 patients, so it's almost closed, and we would very soon are presenting the results with you all. Very excited for that. Another positive result, successful result, cohort was the cohort in which we treated patients with BRCA mutated tumors with a PARP inhibitor called olaparib. We saw, again, very good clinical rate of 58%. And what's interesting here is that we analyzed retrospectively the whole genome sequencing data, and we saw that in 4 patients, they did not have biallelic loss of the BRCA genes, and in all these 4 patients, no response was seen. So we suspect that the not having the biallelic loss might have resulted in olaparib resistance. Another positive result cohort for us was the cohort in which we treated patients with a HER2 mutated lung cancer with trastuzumab pertuzumab, and we saw a clinical benefit rate of 37.5% with a median duration of clinical benefit of 5.6 months. So these are all our success stories, but what's inevitable with signal finding is that there's often no signal, or sometimes no signal. And this is an example of that. The treatments monotherapy, palbociclib, and monotherapy ribociclib, which are CDK4/6 pathway inhibitors. We have discontinued giving these monotherapies because at the end of last year we had treated 112 patients. We saw that clinical benefit remained low. We reported this to our steering group, and in concurrence with the pharmaceutical company and our steering group, we decided to pool all these patients, report on the clinical benefit rate, and decided based on those data to discontinue treatment with palbociclib and ribociclib. So those are the results that I wanted to present. What are our future perspectives? Talking about, well, big data, at least a more comprehensive or a more cohesive database, because this is all based on the Dutch patients, of course. We would very much like to build an international data sharing platform, because one of the biggest challenges we see is that in a lot of cohorts we can only include 1 or 2 patients, simply because the indication is so rare. There's some combinations of molecular targets and tumor types are so rare that we barely see any of them. And when we combine international data, we think that we still have a way of managing to produce results and publish this. And and share this data with the world. So we've actually been working together with Capture and Taper from Canada and the US, but we very much encourage other European countries or European centers to also set up a drug-like trial. Some Scandinavian similar trials have actually started including patients recently. So the IMPRESS study in Norway and the ProTarget in Denmark. The UK is working on a determined study. And in Germany and Italy, they're working to set up a similar study as well. And of course, we would very much like to see a similar study of these, of this design, in the end, maybe even proportion, in Belgium, and would very much like to see cooperation in the future there. So other things that we're doing right now is add to the database with fecal samples in the patients that are treated with immunotherapy to see if the microbiome has some prognostic value when treating these patients with immunotherapy, and we're trying to see if we can combine certain targeted therapies to even further personalize the anti-cancer treatments, and of course improve therapy treatment effects. I'm sorry. So I'd like to conclude with that, with the DRUP, we create ongoing opportunities for metastatic cancer patients by not only providing them to off-label targeted therapies and immunotherapies, but also accelerating the clinical translation of new insights into the use of anti-cancer drugs, and by creating a publicly available database for future biomarker research. I'd like to thank you very much.
Great, thank you, Gijs. Further questions? We have room for 1 or 2 questions. Also for people online, they can also ask questions.
Thank you, Gijs. I hope I'm pronouncing your name correctly.
Yeah,
I'm really inspired by your study. One of the things that I have observed when you presented was that there's a remarkable amount of manual reviewing of the molecular profiles of the person that has to be recruited in the study eventually. Do you think in the future, like advanced analytical approaches could sort of automate these approaches, automate this entire process of matching the intended target with the drug or whatever? Do you have some kind of an idea where you foresee that such applications could also benefit and or even fast track your study?
Yeah, I believe I understand your question correctly, but I think that I definitely see a future where we get the molecular target with which a patient is submitted, and have some database in which we can easily see the results of previous patients with the same tumor type and the same variant that have already received this therapy. I mean that. I think that's the main goal of the study actually. That would be the main goal, to create a database in which you can easily see how a patient would compare to other patients that have previously received the same treatment. I definitely see that in the future.
Thank you.
Okay, one question there.
One quick question. You're generating the data. That's the first step. What's going to be the next step? Are you working with the government on, being able to actually put this data into action and to repurpose some of these drugs? Because, I mean, that's some of the results you're showing are quite staggering. So I hope that you can take it to the next phase.
Yeah.
And is that on the Dutch level, or are you also going to be able to implement it at the European level? How do you see the future of this going forward?
Yeah. Thank you for that very good question. So that what you're alluding to, I think we're trying to solve with what I briefly mentioned was the third stage of a cohort. So that is further confirming the signals that we see. I can briefly say something about the logistics behind the third stage cohort that we have set up. And we are setting up one right now for olaparib, the cohort that I showed the second, that was the second cohort I showed, is that these discussions are very extensive, but the goal in the end is to provide and to publish the data of so many patients that we can publish this to the outside world so that everyone can benefit. But what we're doing in the meantime, while the cohort is filling up, we're in talks with, like you said, our government, the health insurers, and the pharmaceutical company to see how far they're willing to go to, very soon after the completion of that cohort, get this into a regular treatment schedule. So that's definitely something we're working on. We're not just working on collecting data. We're very much actively working on bringing it to the public as soon as possible.
Okay, the implementation in medical practice, obviously that's the main purpose. So thank you very much, Gijs, for your interesting presentation.
Thank you.
I would like to start the second part of this morning. And in fact, first of all, apologies for the ones that are participating virtually. I understood that there were some technical issues, but they should be resolved by now. So also for people participating remote, don't hesitate at the end of each presentation to also raise questions. So this second part will be of a different perspective. We will look to different aspects, in fact, of data science in healthcare. First of all, we will look from the patient perspective, and then we will look from the more ethical perspective on use and reuse of data. First of all, the patient perspective, and I would like to welcome Kaisa Immonen. Kaisa is in fact director of the policy at the European Patients Forum. She is co-chair of the European Medicines Agency Patients and Consumers Working Party, and she is also a patient representative in the EMA COVID-19 task force. Kaisa will talk about the patient perspective on data and AI in healthcare. Up to you.
Is this working? Can you hear me? Yes. Thank you so much for the invitation to speak, first of all, and for the nice introduction. Well, where should I point them? Just here?
Yeah. And then it goes there. Yeah.
Okay, perfect. So my name is Kaisa, and indeed I represent the European Patients Forum. So I want to, before I go into my talk, I want to say a few words about my organization in case you're not familiar with us and what we do. APF is an independent NGO, so we are non-governmental. We're about 20 years old, almost, and we're based in Brussels. And our raison d'etre is to bring the patient perspective into EU health policies, projects and other initiatives, including informal collaborations on health-related issues. So I will, in my talk, touch on some EU initiatives in the field of big data, artificial intelligence. We have 77 members at the moment. They are not individual patients. They are also umbrella organizations, either working at the European level in different diseases or national level patient coalitions. So what are we going to talk about today is really, I'm going to talk about our work on data from the patient perspective. It's all really based on consultations with our membership and our internal working groups. And then I will talk a little bit about the European Health Data Space and a little bit about artificial intelligence and how we see the potential of that. And I'll give you a couple of examples of what we're doing to engage the patient communities in this area. Now, healthcare can undoubtedly benefit from the digital and from the data revolution. It will have an impact on everything, from diagnosis to treatment, to the way healthcare services will be organized and delivered. And at the moment, of course, the progress is still very patchy and uneven. Policies and practices are not always developed with the patient views at the center. But patients see various values and have different expectations from the application of digital technologies in healthcare. From our membership, we got the very key message that the digital revolution should lead to healthcare becoming more patient-centered, as opposed to disease-centered. It should enable better integration, both horizontally and vertically, between care levels, but also between health and social care. It should bring care closer to the patient, of course, and it should provide effective support for patients to self-manage, for adherence, and to improve quality of life. Ultimately, it should also empower patients by providing patients with more information and more knowledge, but also by facilitating patients' involvement actively in the care process. And of course, there is also the expectation that this should lead to greater sustainability of our healthcare systems in a context of growing demand due to changing demographics and disease patterns, and the shortages of healthcare professionals. We've seen during the pandemic an acceleration of the deployment in digital health solutions, although again unevenly. It has showed the importance of data. It has also showed that there are some important issues that are yet to be resolved, including lack of interoperability and common definitions, maybe even a common language. The unequal accessibility of these tools to patients. We've seen that across our membership in the EU. And of course, there has been a bit of an ad hoc approach to innovation because there has been a rush to do things quickly. And this has taken precedence over a systematic evaluation and implementation of really what really works, particularly from the user perspective. Some concerns have arisen more recently also about tracing apps, and there are issues about trust, about data protection, privacy, security, and also the accuracy. We've also seen that wrong data, potentially wrongly interpreted data, or even fraudulent data in research can have a hugely damaging impact. The ways, for example, that COVID-19 cases, deaths, hospitalizations have been and are still being reported and counted in different countries is inconsistent and sometimes incomparable. Furthermore, some published studies, for example, the ones on hydrochloroquine, if I pronounced that correctly, were based on bad data, but they managed to influence healthcare policy before things ultimately were turned around. And these issues ultimately contribute to the public's distrust of healthcare authorities' public health advice when they don't know what to believe. I also want to mention that in the EU context, this is clearly a high priority. It's very high on the Commission's agenda. This was included in the Commission President's mission letter to the European Health Commissioner, Stella Kyriakides. And the priorities there are the development of the European health data space, and also artificial intelligence is a big priority. And of course, it's also a priority for us as a patient organization, given that we need to engage in these important policy shaping conversations. And we think that health systems and policymakers should now take learnings from the still ongoing pandemic to keep the momentum in a positive adoption of technology and sharing of good practices, whilst also addressing the emerging shortcomings and risks. On the slide, you see some, maybe not easily readable, but you can have these afterwards, some key messages around our vision for a patient-centered health data revolution. These are centered around the patients need to be in control of their data. Patients must have at least some degree of control of their data, and I'm not talking today about ownership from the patient side, but control of their data as well as being able to freely access it. So ideally to decide who to share it with, when and under what conditions. Also, those who wish to do so more widely should be given the opportunity to do that. for example, through data altruism or data donations. Of course, as long as the implications of doing so are fully transparent and clear. And that brings me also to the second point, which is meaningful informed consent mechanisms. Informed consent, of course, is a fundamental patient's right and the principle of medical ethics. And the use of data, the increasing use, a reuse of data that's collected for one purpose, for another purpose, adds an additional layer of complexity to the informed consent process. There are already shortcomings in what we would call normal informed consent to participate in research, and often that's not really patient-centered, and the knowledge of the patient is not really increased by that process. It's often about box ticking, having a signature on a form, and this is not enough, and it will certainly not be enough when we also talk about secondary and future potential uses of the data, which may not be even known at the time of the informed consent. Then we would like to be reassured that this data is used to improve healthcare and in the patient's interest and in the public interest. There will need to be more reflection of who owns data and who can use it, and governance frameworks for sharing the data have to be built on ethical standards and on trust. And we also think that improving digital health literacy and data literacy, and I would probably add to that basic science literacy and media literacy, will be very, very important to support acceptance of data sharing and to help people feel more in control and enable them to understand and exercise their rights, whilst also realizing, of course, the benefits of data-driven innovation. The applications and products will need to be more inclusive and user-friendly. This is very, very clear. And it calls for more inclusive and co-designed development process for all kinds of health data-based solutions and tools. And then, of course, I'll come to the patient-centered European health data space in a moment. We think that a sector-specific approach on healthcare and data is important because of the particularities of healthcare and its specific challenges. I will talk a little bit about the health data space in a moment, so I will not go into that now. And also I'll come to artificial intelligence. We think that ensuring artificial intelligence will actually support improved healthcare quality, safety, health equity, and patient empowerment means that we need to think about the benefits it can bring and make sure people understand that, but also thinking about the potential risks and unintended consequences it may have and managing those whilst ensuring robust human oversight of artificial intelligence. So just to mention the European health data space, I'll give you a little bit of a background on this for those who may not be familiar with it. The European health data space, or let's say the Commission's policy on health data more broadly, is a cross-sectoral governance framework for data access and use, and it includes actually the European health data space is included in this cross-sectoral governance framework. It also includes a data act and a review of other policies. But the important thing for us is that this has as one of its explicit goals the empowering of individuals, improving, for example, the portability of data and more control about their access and use of it. So, did I go back? Sorry, I went a bit too quickly there. So just to recap the objectives of the data space, because they're quite important. I said ensuring access, sharing, and optimal use of health data to support healthcare delivery, but also research through secondary use, policy making and regulation. But it has to be done in a way that includes preservation of privacy, that is secure, timely, transparent, and trustworthy. And trustworthy, I think, is a very important word here, and has appropriate institutional governance. The second objective is about a single market, of course, on digital health for services and products. And the third is about enhancing the development and deployment and application of trustworthy products and services. And here we are expecting a legislative proposal in the first quarter of the next year. So what are our views then as a patient community? We have consulted our members on several occasions on this, and we think this data space initiative is very important, and it can bring some needed coherence and clarity to the health data landscape in Europe, at least, whilst also having a positive impact on digital health more generally. Our members and our internal working group members have identified 7 areas and actions that the data space should address from a patient perspective. You will see them summarized on the slide. But in a nutshell, these are barrier-free access and control by the patient. Patient safety has to be at the center of everything. Harmonization, whilst also accommodating the EU's different health systems. To address health inequalities, and certainly to avoid exacerbating current health inequalities. To address ethical and practical challenges, and to make sure that digital transformation adds value for patients and responds to their needs. I think that's at the heart of everything. Most importantly, for the data space to work, it will have to be more than just a large-scale flagship European project. It must reach patients and citizens. It has to be co-shaped with them, be accepted by them, and ultimately deliver for them. The second part of my talk will be a bit about artificial intelligence, because this is a topic we have recently started to engage with, and it will undoubtedly have huge impacts on healthcare. It could provide benefits on many different levels, of course, from improving population health to improving the way healthcare systems operate and to support healthcare-related innovation, of course. And patients may feel the impact of this throughout their entire patient journey, from self-care to prevention, diagnosis, treatment, but also care delivery. But as with all new technologies, there can also be unrealistic expectations, and there may be challenges. And I'm outlining a few of the challenges here. We think that one of them is the availability of very large amounts of good quality and unbiased data on which artificial intelligence depends. It is possible because we, as societies, have certain biases, and if artificial intelligence tools are trained using data that's taken from society, it can simply recycle the societal biases that are inherent in the data, and this can entrench inequalities, so it has to be carefully considered and managed. The reliability and safety are a particular concern for our patients, particularly because in healthcare an error can have a serious consequence. They also stressed the ethical issues, including the risk of limiting human autonomy and maybe losing human oversight, and the lack of patient involvement in designing and developing policy and applications for this. And one of the issues here undoubtedly is the lack of knowledge on this topic in the patient community, which can also lead to a lack of trust. So that's why we have started a capacity building initiative on artificial intelligence for our members, and I'll talk about that in a moment. I want to give a few key points quickly about the survey we did on artificial intelligence, which we did with our members. We thought that the best way to start our work was to ask them some questions and try to get a baseline idea of what their awareness and knowledge is. So obviously the respondents identified several potential positive impacts of artificial intelligence to support more personalized care, to support self-care and to provide information, to improve quality and efficiency of diagnosis and innovation, and to support health systems efficiency. But they also identified challenges, and some of them are exactly what I already mentioned. And one of the ones that I didn't mention, but it's very important, is when something goes wrong, for example, there's an incorrect diagnosis or some kind of other error, who will be responsible for that? Patients would like to be reassured that there is someone responsible. And they also don't want to see human interactions replaced by technology. In terms of knowledge, our members felt their knowledge was very basic. There were only a few respondents who felt that they knew very well about artificial intelligence and its implications. And several did not have any idea of how it could actually be applied in healthcare. they also were not really aware of current uses of it in their disease areas. Overall, they had quite a level of trust. Maybe this sounds contradictory, but it tends to be a characteristic of our patient community. Patients, I think, compared to the general population, tend to have more trust in science, more trust in health authorities and healthcare professionals, perhaps. So there is some trust, but we got the impression that the level of trust might depend on the nature of the decision AI is making. For example, what are the risks if the decision is wrong, and whether or not this is supported and recommended by healthcare professionals. So again, healthcare professionals are a very important link for patients there. They've also asked for certain knowledge, easily accessible basics, let's say, on what is AI and how does it work in healthcare, knowing your rights, knowing the risks, and knowing how these outputs are used are amongst the things that were mentioned. So building on this, we responded to the consultation on the Commission's white paper on artificial intelligence, and we laid out 9 steps towards a European ecosystem for trustworthy, ethical, and safe artificial intelligence in health. And again, it sort of repeats what I've already said, but basically ensuring safety, ensuring that it improves healthcare quality, addressing challenges like data biases, ethical issues, and the human aspects, transparency in research and innovation, better European cooperation, and boosting citizens and healthcare professionals' skills and digital health literacy, that we think that's a precondition to successful exploitation of artificial intelligence. In terms of defining risks, which is mentioned there, we think that since the European Union's approach on risk is linked to more or less restrictive assessment procedures, it will be really important to carefully evaluate and define what could be considered low-risk or high-risk applications. And of course, assessment mechanisms for safe and ethical artificial intelligence, probably both ex-ante compliance and ex-post enforcement with independent bodies involved. So then just the last part of what I'm going to say today. I hope I'm doing okay on time. Okay, I'll be quick. I just want to mention a couple of quick projects we're involved in. And obviously we are involved in many European Union funded projects, but the 2 that I will share are the Data Saves Lives initiatives and AI Knowledge Hub. So this AI Knowledge Hub is a new initiative. It's a resource point on artificial intelligence in healthcare for patients, but also for citizens or anyone who's interested. You'll find a different work in the hub, including a webinar series called Understanding AI, different capacity building resources, and we will be populating this also with policy papers, some research papers, and other materials. And this is really, this work is funded by a grant from the European AI Fund, and it includes all of this sort of package, and we are expecting to publish also a position paper on AI in 2022. So this is a really nice new initiative for our members. The second is Data Saves Lives, and this you may be aware of, some of you. It's a multi-stakeholder initiative that focuses on communicating the value of sharing data. We're hosting the secretariat, and we have several patient representatives in the group. And really the aim of this is to build awareness and trust on data and responsible health data sharing. For example, there is a European health data website for patients. There are some multi-channel media resources and a health data community, as well as a network of health data ambassadors at national level, which will help cascade these messages. We are now looking to maybe take this collaboration further by having some national Data Saves Lives platforms. So I think I'm done. I think just to conclude, we recognize that data broadly, artificial intelligence specifically, have the potential to disrupt and transform healthcare and to directly affect patients. So we have taken a position to proactively engage in these debates around these topics and to provide information and tools for our membership to support their capacity in turn to reflect on and to engage. We're in a time when important policies are being shaped concerning the future of the digital transformation, and this must be done in partnership with patients at all levels. I think that's my main message to you today. And just to close, this is the sort of vision we are aiming for. No longer patient-centered healthcare, but real partnership at all levels. Thank you for your attention.
Great topic. The patient being part of it, and just stay with us for a couple of questions. Any questions here from the room? The patient perspective and the patient as a partner in, there at the back, at the right side.
You briefly mentioned that patients in general are more willing to share their data or to collaborate. Could you elaborate a little bit on that?
Sure. I mean, we've done a survey, which I wasn't able to share today, but we've done a survey with our members on electronic health records, and also which included also questions on willingness to share their data from their electronic health records. And we can see that people are very willing to do it, under certain conditions, of course. But this is, it's actually in line with other research we've seen that has compared patient groups with the general public. I don't have the references in my head right now, but it confirms other research. And also another survey on this topic was done by the rare disease patient community led by Eurodis, and it derived exactly at the same result. There are certain things that will affect patients' willingness to share their data or to agree for it to be shared in future, which may include things like for what purpose will it be used, who may be using them. Some people have different preferences, but in general, people are really, they recognize the value of it and they want to either help themselves or altruistically help other people. So I think probably that's where it comes from, if I can speculate.
All right, thank you.
Okay. Other questions? Here at the front. Wait until the mic is there. Yeah, you can go ahead.
You mentioned that you would like to have the patients get better control on their data. Do you see an opting in for the secondary use of data?
I can't really answer that today because we're still having a discussion internally about that, as well as about the term ownership, which is quite, let's say there are different views about how we should frame these things, but that's something we are discussing at the moment. Yeah.
Indeed, a topic of great interest.
Not even consensus in our community yet on that.
Okay, good. Thank you very much.
Thank you.
Good, and now we'll go to another important aspect in data use and reuse, and that's more the ethical aspects. And I would like to introduce Heidi Mertens. Heidi is professor in medical ethics at the Ghent University, and she's also one of the founding members of both the Metamedica Consortium and also the Bioethics Institute in Ghent. And what is very interesting is she has a great interest in big data, and especially because she is also participating in a European-funded project, a European Research Council project, where she said there is a lot of innovative and disruptive innovations that are impacting, in fact, how the ethical perspective and ethical frameworks are perceived. So very interesting to hear your perspective about the ethical perspective on big data in healthcare and achieving the good, but not the bad and the ugly. So please, Heidi.
Thank you. Thank you also for inviting me. I know if you're very enthusiastic about a topic, it's always nicer to hear the big success stories than to hear the ethical concerns, but I'm happy that you made time for this nevertheless. I have no commercial interests to disclose. I just want to explain my title first. So I know that I think in sharing data and in big data in healthcare in general, there's a lot of potential, a lot of good that can be achieved, and I think I don't have to convince this audience of that matter. But what I would then like to focus on is what could potentially also go wrong or where the ethical concerns are located. So we have certain concerns, as has been also just now mentioned, over privacy, confidentiality, but also just in general about clinical care. Will it really improve or not? And many of these issues have an underlying issue, which I would call the ugly then, which is a big power asymmetry, of course, between the individual patient or the individual citizen and big companies processing the data. So I kind of made 3 categories for today. First, negative impacts on overall quality of healthcare that we should watch out for. Negative impacts on the quality of healthcare for specific groups, and then some of the individual impacts like privacy and confidentiality and ownership. Okay, so first let's look at the negative impacts on overall quality of healthcare. So as we already just heard also, of course, leveraging big data requires good quality data, structured data, and an assurance of interoperability. I think you all are familiar with the phrase garbage in, garbage out, so this is obviously something you want to avoid. So no matter how large your quantities of data are, if the quality is not good, you won't have good outcome data. Okay, so that's all good. But what are good quality data for research are not necessarily good quality data for clinical care. And I want to take the electronic health record as an example here. I think if you interact with physicians or the physicians in the room will know that the electronic health record, although it's great for gathering data, is not something that people are enthusiastic about in the field. So the data that you put into the electronic health record has to serve several purposes. So it's required for well, clinical care in principle, but also mainly for billing, I'm afraid, and then secondary also for research, for quality control, for disease surveillance. Now, for some of these purposes, it would be better to have very structured data, coded data, for example, for billing or for research. But for clinical care, it's not necessarily better to structure it in codes because a lot of information then also gets lost. So the narrative aspect of this is sometimes difficult to include. And I want to quote or paraphrase my colleague Tanja Moerenhout there. You know, messy real-life situations don't really translate well into code, so you are losing a lot of the context there. And there we can see also in research that there's quite a bit of conflicting data on whether or not this electronic health record actually increases the quality of care. Then also secondary, so we need to formulate this data differently. While the physician is inputting this good quality data, of course, the physician is not interacting with the patient. And that is something that physicians also very regularly point out, that their job has been transformed from a very interpersonal interaction with the patient to a more of an administrative job, let's say. And in that respect, it has been linked quite often with burnout in patients. Of course, there's a lot of differences here between different contexts, but I think it's at least important to be aware that this is an issue. So if I realize that for research you need this good quality data, but it also comes at a cost. Okay, but if we move on then, so let's say that we have the good quality data, we have it nicely structured so you can use it for research. Then it's, I think, important to keep remembering that knowledge does not emerge from data sets. You have to design algorithms to get valuable information out of these data sets. And it's important to realize that choices are being made, their value judgments are being made, and that these, well, especially when we're looking at clinical care, the way certain, if I'm thinking now, for example, about clinical decision support systems, as long as a physician knows what those criteria are, what those choices are, those value judgments, they can also adapt it whenever necessary. If this is not the case, then it's of course harder to do this, especially if they don't have an insight in what's happening. But I don't want to go into that too much. I want to go further here to also point out that statistical significance is not necessarily clinical value. I think you're also quite familiar with this concept. And I want to give you an example of how bad predictions can also cause more harm than good, even though you have statistically a good correlation between certain data. So you might be familiar with this study. So it's an external validation of the EPIC electronic health record system, where there's a predictor for sepsis, so which is one of the major causes of death in hospitalizations. And there you see, so the algorithm that was developed, it is statistically valid, right? So it does detect correlations between certain clinical variations and the onset of sepsis. But there was one clinic that externally validated this. I think a US clinic, I think it's Michigan, if I'm not mistaken. And they noticed that, so in 7% of their hospitalizations, there was sepsis, so in about 2,500 cases. But of those 2,500, about 1,700 were not identified by the alert system in the electronic health record, so almost 70%. And nevertheless, an alert was generated in 18% of cases, with a positive predictive value of 12%, so meaning that about each time the alert goes off, about 1 in 8 times, there was actually a case of sepsis and not in the other 7 cases. Now, you could say, well, but it's better to have something than nothing. But what happened in this case, or what several centers have reported, is that due to this high number of alerts, there's alert fatigue, people start ignoring the symptoms. And also, on the other hand, people are saying, well, we don't really have to monitor for sepsis like in person because we have the system doing it. So this basically leads to well, worse clinical care. And the major problem that was flagged by the authors of this paper is that it's actually quite difficult. So you can do an external validation study, but it would be very convenient if the people who are making this system make their data, don't keep the data secret, the data that they have in their validation study, while it is now proprietary and under IP. So it's quite difficult for medical centers and physicians to actually evaluate a system that they are using. Yeah, also more on a different note, I think the belief in the datification and digital twins, oftentimes there seems to be a belief transpiring that you have more objective data and therefore better data, better quality data, more truthful data than through subjective data. I think we have a couple of examples quite clear right now why that is not necessarily the case. I think here in Belgium, those who have downloaded the Corona Alert app, I think might be convinced by now that maybe if you just ask people who have you seen, you might sometimes get a better response than looking at the app. Sometimes your Bluetooth is off. Sometimes someone else is walking around with your phone. And my son sometimes plays Pokemon Go on my phone because he doesn't have a phone, so we put it on mine. If he's walking around meeting people, then this is not really valid data. So that's important to just keep in mind, that it's not because it's seemingly objective that it is more truthful. Sometimes subjective data are more truthful than objective data. Okay, so in conclusion for this first part, I think, and I'm paraphrasing Barbara Prainsack here, I think it's important to not lose sight of keep including thick descriptions, so narrative data, patient data, next to the quantified digital data. So I'm certainly not saying that digital data is not useful. I think we've heard great examples this morning of how it is, but it's just important to keep in mind that you shouldn't narrow it down to only that. That the personal relations alongside this machine learning and automation need to be included, and that we should be aware of ambivalence in the quest, I guess, for precision and clarity. Okay, so going now to my second part, the impact on specific groups. There are some concerns there, and I think you probably also already heard about this before. So I made 3 categories, although I realize that they are overlapping. But I first want to have a look at representativeness, biased data sets, and confounding variables. Yeah, this is a quote just saying that even if you have a lot of data, it seems if you have a lot of data, then everyone is included, right? Or you have a higher chance that everyone will be included in the data set. But it doesn't necessarily mean, well, first of all, it doesn't necessarily mean that everyone is indeed included, and also that the representation is correct, so that you have the same, that everybody is equally represented, let's say. That's not rocket science, but I want to give you an example in a second where you will notice what the problem is. So there are a number of biases at play, but I picked out one because I think it's the most important one, sampling bias. I think it's quite well known that we are losing certain populations in big data research because they have less access to healthcare. And oftentimes this is also goes hand in hand with lower levels of trust in healthcare. So even if there's an opt-in system, certain populations are less likely to opt in than other parts of the population. I think especially in the US, this is quite clear in terms of, for example, the African American population having lower levels of trust in healthcare and thus are less likely to offer their data out for research. Which leads to under or overestimations of risks. I think this is a nice example. So these are data from a GWAS study, so genome-wide analysis, association studies, I'm sorry. And you see here, so the red are European samples. And it's, the x-axis I seem to have lost, but that goes through time. And if you see the population, the global population, if it would be representative, you would have to have the top slice there, the top red slice of European ancestry people, and then East Asian is the blue, and South Asian the green. And Africa, for example, is the purple one there, and so it should be quite large nonetheless. But you see in the data that we have in existing data sets, it's mainly people of European ancestry. Now, what this means is, and that you can see on the right, that if you have a predictive model based on this GWAS set, and you take the European population as a reference, so as impact 1, let's say, of your intervention, then you see that depending on which, what is your ethnic background, the predictive value of the model will be a lot worse, and especially for people with African ancestry. That's not only because they are so little represented, but also because the genetic variety is huge there. Okay, so then the second, group of problems is harmful profiling, stigmatization, and systemic injustice that we have to be careful for. I'm thinking that many of you probably already also noticed this study. So this is a study for 2 years back where an algorithm that was very widely used in the US was analyzed. So the algorithm, in first instance, it seems to make sense. So the idea was we want to know beforehand when a patient is in our clinic, what is the chance that this patient is really severely ill and will spend a lot of time in the hospital. And so the algorithm was set up to see if people with similar characteristics that previously were in the hospital, if they had a long hospital stay or not. And that way you could predict if this patient will also need a lot of care or not. Now, what was noticed that at a given risk score, Black patients were considerably sicker than white patients. So even though they had the same score, it was very noticeable that they were a lot more ill. So why did they not score higher earlier, let's say, when they were not yet that ill? And the answer was that of course, people with African American people in this data set, due to lack of access and lack of money, were spending less time in the hospital, but not because they were less ill. So, but what the algorithm then achieved, let's say, is that even though they were already getting worse care, they were now even more getting worse care because they were flagged as being not so ill, whilst they were actually as ill as people of European ancestry. And so if you correct for this, then the number of patients that should have been receiving additional help, it should have gone from 70% to 47%. Now, this was corrected in the meantime. So I guess in a sense, it's also a positive story that if you find these problems, you can correct for them. But it's important to go look for them and to notice them when they are present. And of course, trying to fix them requires transparency and explainability of the algorithms. Another example of how health inequalities might be reinforced by big data research and automated decision making. Is this one. So this is a tool that you have in electronic health records where you can manage overbooking. So you have no-show patients. So you have patients that don't show up for a consultation, and then this program kind of looks at who has, let's say, characteristics that make it very unlikely that they will not show up, and then you can double book those patients because they, then you have a high chance of not working as a physician because somebody doesn't show up. Now, some of these variables are not very, very problematic. For example, prior no-shows, it makes sense if somebody didn't show up earlier. But for example, also language and ethnic background is used there, insurance type, and I think there you see the problem coming. So it means that basically if you have the same ethnic background as other people who are not showing up for their appointments, but you are a very good patient and you are showing up, then you will get less care because your appointment will be double booked. So you will only have half the time with your physician as other people. Although, of course, it's not my fault that other people that look like me don't show up for their appointment. And I guess if they would use this just to send extra reminders, you could say, well, that's a bit stigmatizing, but yet it's positive also for the patient, but of course not if you are using it for overbooking. And then a final point here, this is a study that was recently halted 2 months ago. So it's a big study on autism in the UK. So it's gathering genetic data. And to make it very clear, everyone in this study signed a very explicit consent. So everybody that was in the study consented. And yet there was basically a boycott from the autism patient representative community. Because they felt that this was very stigmatizing research, and they were very concerned what would happen with this research. So if you have a list of genetic mutations linked to autism, what will be done with this? Will this mean that people will get prenatal screening and abort children with autism, for example? So this is now halted in order to get more patient involvement, and we'll see what happens next. But I think it's just important to know that these problems exist so that you might want to be mindful of them, I guess. Maybe just very shortly, why is this important to think of these populations that are maybe already not well served in our community? This is a paper that's 50 years old on the inverse care law. So obviously, or oftentimes we see that healthcare is more, and this again is not news, I think, tends to help people that are already well off more than people are not so well off. So I think it's kind of time to reverse this law. Now, very shortly, because I know that I'm running out of time, I think we know that many patients are alerted when they see these kinds of headlights of big companies, investment banks, and big tech companies buying up their data. So here we come to the privacy and confidentiality issues. I'm going to try and go a bit quick here. So I think it's been touched upon before, but it's not so obvious whose data, health data is. I think ownership legally is not it's not even an existing concept in law, ownership of health data. So I think we should be thinking about how to organize this. So we have two ways of approaching this, either to say, well, we need to put the citizen back in charge, so we have to go for empowerment, and their ownership model is oftentimes mentioned, or we have to go for more oversight and data stewardship. I think both have very different characteristics. So individual control, you have to refer either to property rights, which I think is difficult, or civil rights, which means that, well, for example, in civil rights, your property rights are not transferable, of course, or your management rights. On the left, you will have stronger consent requirements, less on the right. So the right, you will be talking more about data commons, data altruism, and so forth. I think, as I said already, the individual control of health, I think, is intuitively very appealing, but it does come with a number of problems. For example, are individuals more likely to prevent privacy breaches? I think we see in how people manage their data in other spheres that sometimes it's very, they're not always acting in their own interest, or they cannot always act in their own interest because they can't, as an individual citizen to react against a Google, or it's difficult. I don't think we can live without Google, so we are offering up our data, but we're not really clear about that, or we don't really realize it all the time. citizens might be trading away basic rights for little value. And I think especially in the US, there are some companies that would be very happy to have a property type of model so that they can easily get data from citizens. How to get an informed consent, I think, will be difficult. There are several models: a dynamic consent, meta consent, layered consent. But how will you operationalize them? So those are some challenges. Also, for the collective model, there are some challenges. The oversight mechanism, I think, would definitely require proper representation of citizens. And it should be transparent, and this is all, it has also already been mentioned, but I think trust is really a key word in all of these discussions. If you don't have the trust from your patients, from your citizens, then you are at one point going to get a big backlash. So if you want to get your data to work, you really have to work on trust, and not just making people trust you, but make sure that you are trustworthy, so that you are that people are right about trusting you with their data. So, as was also mentioned just before me, people are open to share their data, so for the common good, but they are wary also of what might happen. So this trust is very important, and I think it's important there also that we can appeal to solidarity and data altruism, but it can't be like a blanket, like you have to give your data for the common good and then we can make a lot of profit. That doesn't seem right in people's head. If they have to give it up for free, then why is someone else making money out of it? And then two aspects that are important there is reliability, but also value congruence. So if you act in a way that the patient thinks is good behavior, that they can agree on, that aligns with their values, they will have more trust in what you are doing than if you are not. Okay, and then, but I'm going to end with this. I think a major caveat there that I don't know how to solve is that currently the big players on the health market are not typically the players that generate a lot of trust in patients right now. So the big tech companies, and I think they realize it themselves as well, one of the big threats in their position on the market is consumer trust, especially regarding privacy and confidentiality, that they are not, that they will have to manage somehow. They will have to regain the trust that maybe they have lost in the past. But I'm going to end there. I'm sorry for rushing through a bit, but I think you're all getting hungry, so.
First question coming from the people taking part remote. And it will appear on the screen, I suppose. There. Oh, okay. I was switching screens. So I will read up. What is the role of patient organizations in advocating towards policymakers, regulators, to facilitate the work of corporate research in partnership with patients?
Yeah, I think this is a question mainly to the previous speaker as well. I think there is a really important role for patient organizations, because as I said, this trust is really, really fundamental, I think. Once you lose trust, I think that's what we also saw, for example, in biotech, in genetic engineering of crops. If you don't have the trust of the public, your science can be great, but it's very difficult to change that perception. Once people are thinking, people are doing wrong things with our data, it's much more difficult to turn it back than if you involve people from the beginning and make sure that you're not doing anything with the data that they don't want. So I think there's a huge role for patient organizations and patient participation.
Great. Okay, another question here from the front. Just here, in the front, yeah.
Thank you very much for a very interesting presentation. You talked about the bias based on racial profile. Is it even allowed in Europe to document racial information? I see the very importance, but it's very hard to get racial information, and whatever data is available is usually from the US and is also only fragmentary. So how do we deal with this? Also given, obviously, Europe's legacy with racial profiling, how should we solve this?
Well, first of all, you are right that in many European countries it's a lot harder. In the UK, for example, not that it's quite standard also to indicate your racial background. But even if you don't have the actual race, there are a lot of confounding variables that will lead you that way. Like, I know that there was an algorithm where they took out race because it was also prohibited by law to take race into account. But then, for example, postcode became the proxy for race because in many certain postal codes, there were more people with certain ethnic backgrounds. And there you have the danger that people say, oh, but we're not doing racial profiling. We're doing it very objectively because it's just an algorithm. But in fact, you are using a proxy for race. Same for example, gender as well. Sometimes you say, well, we have to take gender out, but if it's an ovarian cancer patient, then the gender is in there somewhere. And your algorithm, of course, is not. I mean, it's not thinking in racial terms, but the algorithm will make this link to gender. It will. So I think it's very hard to take it out, but that's why it's important to have a transparent algorithm. I think because that way you can correct for it. You can look where the bias is, and you can notice, maybe it's in a postal code, or maybe it's there or there. Yeah.
Okay, good. One question. There's here one.
Thank you very much. Outstanding presentation. You can see clearly that there is a strong bias towards the US in lots of the data sets and lots of the questions. Not only the racial, electronic health record usage, but one of the 2 points. One of the aspects when I see your categories, I see that one which is missing, it is often when technology tries to answer questions that clinicians don't have. And, as I'm the chief data officer of Institut Curie, and I have lots of cases where companies come with solutions and I say, there is no interest whatsoever from the medical point of view. It's a clever algorithm, but there is no need for that. So there is a risk of getting all these Me Too that they want to go there because it's very trendy to use artificial intelligence. But a question I have, because I have a number of discussions with ethicists in France, and I see that you limit the view to the legal jurisdiction, but as an ethicist, what's your take in whether we should inform patients? We're talking about developing algorithms, analyzing data. We have consent to develop those algorithms, but should we, because that's the position for some ethicists in France, should we get additional consent when we are going to use algorithms which were developed on the basis of artificial intelligence? Should we inform patients that we use a tool which has been developed using prior data, using one of these algorithms? What's your take as an ethicist?
If I understand it correctly, so if we have to tell the patient this treatment you're getting, it's being advised by an AI. Is that your question?
It is not simply that alone. So we have, sometimes ethics goes beyond the law, right? Even more restrictive. Yeah. In this particular case is whether we should inform patients that their information might be used to feed an algorithm and develop a solution, one question. And the other question is, once we are going to use that question, whether we should inform patients that information taken from prior data led us to that solution.
Yeah. I think it's a difficult, and in principle, I would say the more transparency, the better. But we also know that if you systematically give people information on a certain aspect, like for example, if you tell them, oh, beware, this is made through AI, then people will start thinking, oh, there must be something wrong with it because it's AI, because why would they otherwise be telling me every time, right? So it's a bit the same as if I can refer back to the labeling of GMOs. People are, even if maybe it would be good, it's good to inform people, but at the same time you start thinking, oh, is there something wrong with this because there's a label, so there must be something wrong with it. So I think it's difficult. Yeah, I would say, well, I think it's good to have both systems in the sense if you have oversight, making sure that the AI that is being used properly, and that people's rights and interests are not being harmed in a systematic way, then I guess your requirement for explicit consent of the patient goes down, because you know that the reason why we have informed consent is not only because of autonomy, but also, and mainly I would say, to make sure that people are not exploited or forced to do things that they don't want to do, or that they're being taken advantage of. And you can also avoid taking advantage of people without a very strict informed consent for each and every procedure, so with maybe broader consent. But that really requires very strict oversight. And I think at this point, it's going to be very difficult, I think, to, just because also there are so many algorithms and because they are so difficult to understand oftentimes, to be able to tell the patient, well, it's AI, but you can rest assured that this is, this is trustworthy. So I think in this instance, I would, I guess, inform the patients as much as possible. But I do realize that there's this backdrop, drawback that you might make them more worried than maybe necessary also in some cases. It's a difficult one.
Yeah. Great, thank you very much, Heidi, for your presentation.
You're welcome.
Okay, so we are at the end of this morning session, and we went through a lot of very interesting stories. First of all, there was the perspective from the healthcare provider, where Gabriel explained us about the Maccabi example, where you obviously, during many, many years already, I think more than 15 years, developed, collected data and are running registries where large amounts of data have been collected and have also, very important, been validated by clinicians so that they can be reused for research. And you even said, well, we are extending that with patient-reported outcomes with quality of life data to further enrich this information. And then you explained, yeah, we can use it for many different purposes. It could be used, in fact, more descriptive, and you gave a nice example of that for HPV vaccination, where Facebook has been used, a Facebook campaign has been used, but where you said we have to be very careful in tailoring this campaign to reach the right group of patients and not segment. Then also more a predictive use and a prescriptive use. And there you gave the example of using, in fact, data for prediction in earlier identification or even interception of colorectal cancer patients. And then also at the end, you described the K-Health app, which is an app based on AI, which could be used, in fact, to support patients in consulting physicians, but then very tailored to their personal needs and situation. After that, we looked into more the research perspective of data use, and Gijs explained us how in the Netherlands, a more extensive, let's say, study is done based on a genomics guided precision oncology approach, where, Gijs, you explained how extensive profiling of tumors have been made, and then also matching with a broad range of different types of therapies, even off-label, so to have better fit of a tumor profile to the individual patient. And based on that, do retrospective analysis, but obviously also with the aim to use it in daily care practice in a more prospective way as well. And one very important call to action that you made at the end, Gijs, was we have to work internationally and pool data from across borders and have international data sharing platform, especially in the more rare cancers where few data is available. After the coffee polls, we took another perspective. We looked into the patient perspective, where Kaisa introduced us into how we should involve the patient, and where we have to design data infrastructure and use of AI with the patient as being part of that design process. So, which is really like a patient-involved and patient-centered healthcare data inclusion. Guys also explained, in fact, how the patient can be empowered, and that should be done by also more knowledge being explained to the patient, involving him, raising the knowledge of the patient, but also to help in helping the patient himself better in terms of care. You also explained that COVID, and I think that's one of the nice side effects of COVID, if you can say as such, that it has accelerated the development of digital health solutions. but that we have to think also about distrust in this space, especially tracing apps or even questionable use of data. So we have to really be very much conscious about if we apply more and more data and digitization in terms of, is it a good use of this information, and can it help, in fact, the patient forward? You also explained a very important initiative on the European level, the EU Health Data Space, which aims to create a single data market here in Europe. And of course, also very important for patients is that it has to have a meaningful patient consent, and we had later on also the ethical perspective of that. So how to have it as a meaningful way, but also think about a good governance framework around that, that also takes into account the ethical aspects that Hedy explained. Data literacy, which is also, of course, very important, but a very clear message that she made is patients have to be involved and co-design, co-engineer solutions. Hedy looked then into the good, the bad, and the ugly, where she explained to us that a power asymmetry between individuals and larger groups, larger organizations, companies, that something like that has to be really be conscious about and think about how we can create the right balance. First of all, she explained good quality data is, of course, important and is required for performing research. For creating evidence. But we have to be aware that based on this, we are making choices. We also have value judgments. Well, if it has not been set up properly, we risk, in fact, to make choices on things that are perhaps not based on good quality data. Bad predictions, she said, do more harm than no predictions. So we have to be conscious in applying all kinds of technologies and data interpretations without being well conscious about the biases that could be in data sets or wrong representations in data sets on which then algorithms are built. And she explained a couple of examples in terms of racial biases or certain biases that could impact decision making or not the right balance between different populations. So, in fact, at the end, she explained there's also a very important concept of consent, whether this should be done more on an individual base, so individual consenting, or rather be a collective consenting and a collective control aspect, with both advantages and disadvantages, but with a lot of quick speed and development. Well, we could think perhaps it's difficult for an individual to still judge on all these different new technologies and if they are trustworthy or not. So at the end, trust is the major topic here. If we want to further continue to use data, enrich data, and use that for decision making, trust will be extremely important. And we have to think about creating good balances, good governance frameworks to support this. So that was in a snapshot what we traveled through this morning in the different perspectives on data and digital. So we have now lunchtime, and after lunch we will split in two groups. There will be a group on federated data networks, which will go to the second floor, to the studio. And there is the group on data utilization, which will remain here in this meeting room. And these parallel sessions will start after lunch at 1:45. So 1:45, we reconvene here, and then the second floor, the studio, for the continuation of this seminar. So enjoy the lunch. And also again, network.